Welcome back to another video. So let's take a look at how generative AI has advanced regarding computer-aided design modeling. I'm currently over here on the CSM platform within the showcase, and if I will go all the way to page 4, we're gonna see the following part over here. So we see this has been created by Johnny Balvin, and we see how the sculpting of this will look. So generative AI on CSM, they added a new algorithm which is called Sculpt, and this will mostly generate a mesh that we can use within other solutions. What I want to discuss over here are some aspects regarding CAD models. So we see this flange over here. We see that it has two ribs over here. But if you're going to take a look at the profile of the rib, we're going to see that some of the elements will be like that. So they will not be well defined as ribs, since that profile will change. Usually for ribs, the profile will not change. And some other aspects are regarding the cylindricity of the part. So we see over here, this is a little bit oval over there, and it's mostly pronounced over here at the top. But let's better analyze this within a CAD solution. And afterwards, we're going to compare that with some 3D scans of some industrial 3D models. We're going to see that the main advantage of 3D scanning is that, one, we're going to have an accurate geometry, but we're still going to see that generative AI has taken some huge leaps. And keep in mind that over here, the input was only one reference, which is this one, this image, and the output was the following model. So consider that this only has so little input. The model is quite good. So we see over here on an adjusting lever, we're going to have all of those elements well defined. So this will be close to a perfect circle over here as well. So that's really important when we are doing reverse engineering. But let's get started with this. So I will download. As we can see, you are not required to be logged in. You can just go ahead and start downloading elements from the website. And if I will extract this over here, we're going to see the following session. There will be multiple file formats, so we're going to have an FBX, a GLB file, an OBJ, and a Sculpt. So none of them will be compatible with CATIA. We could try to import the OBJ within the Imagine and Shape workbench, but it will not work since this will be quite complex. But I will start Blender. So in this case, I will start Blender 4.2. And I will go to File, Import, and I will import the FBX file. I will go within Downloads. If I will filter this, we're gonna see that, let's say, initially I need to take this out from the archive. So I already have that. Okay, so it's on my desktop. So I will go on my desktop. This will be the session for the sculpting, and we have the file over here. Now, one of the main drawbacks of generative AI is that in this case we don't have any input. So imagine that this flange is quite large, considering that the default cube within Blender will be 2 meters. But this is something that can be further improved. So we could specify one length over here, and then the model will be adjusted. That will work similar with photogrammetry regarding 3D scanning, so that is not a problem. Over here I will just scale this to make it smaller, so something like this. Afterwards I will take it back within the origin, and I will delete the default cube. If I also want to change the orientation of this, I can easily select it, rotate it. I can select the x-axis, and I will rotate this minus 90 degrees. Now, with the object selected, I want to take it within CATIA in order to analyze some elements. So if I will go to File, export, I will choose the STL file format. So on my desktop, I will call this, let's say, flange STL, selection only, because I only want to take this mesh, and I have that exported. I will jump back to CATIA, and within Digitize Shape Editor, I will import the mesh. So I know that this will be an STL. The file will be on my desktop and will be the following. I will initially import this as the file unit set to millimeters. We're going to take a look at the file size, if this will be correct or not. We can do that using the information. And we're going to see that in this case, this part will be really tiny. So we see 0.38 millimeters. So I will just select it, re-import it. And over here I can either change the file unit from millimeters to meters, or I can just change the scale factor. So I will change this to 1000. And if I will select it now, we're going to see the dimension of this flange are the following. Good, so we have the orientation of the object, which will be the same just like within Blender. You see how I rotated that, and we're going to have the z-axis going upwards, and within CATIA, the z-axis will again go upwards. Now, I will go within the workbench quick surface reconstruction, because I want to see some basic features that we can reconstruct over here. If I will go over here on basic feature reconstruction, for example, over here on the bottom part, we see that this should be a cylinder. So we see it over here within the initial reference. And we know that mechanical parts like this will be cylindrical. So I have the possibility to go over here and do a brush selection, and I will select multiple areas over here to define that cylinder. And we're going to see what radius that will have and what would be the best fitting of it. So I can also add additional selection elements over here. If I want to remove some of those, I can just hold down Shift and I can unselect those. I will slightly rotate to select multiple areas over here, even though afterwards I have the possibility to rescale that cylinder. Now, if I will click OK and I will hit apply, we're going to see that CATIA will try to fit that the following cylinder over here. If I will click OK, that will give me that cylinder. We're going to see that in this case, the deviation is not that high. If I will select this point cloud and I will add some transparency to it, we're going to see that over here we have this defined within the same radius, and only over here on the sides it will have a certain deviation. If I will go with the measure tool and I want to read this radius, in this case the radius will be almost 80 millimeters. So considering the scaling that I have done within Blender, and afterwards when I imported this within CATIA, we're going to see that the overall cylindricity of this part will be quite good, even though this has been created by a generative AI tool. If I will go forward and do the same over here on the top, so I will select the point cloud, I will go again for a cone, and if I will do a selection over here, I can still maintain that transparency. And let's take a look at the following radius over here. Because within this viewport, we see that this is quite deformed. So this will be more as an ellipse, not as a circle. So let's see, that cylinder that will be fitted over here will be something like this. And yes, just like it's visible, we're going to have a high deviation over here on the top from the original element. We can also do some deviation measurements within CATIA, but in this case this is quite visible and it's not mandatory. Some other aspects that are not well defined are those ribs, just like I previously mentioned. Now, if I want to define a plane, for this bottom section, I can select the brush and I can filter some points over there that I know will be planar. So those as well. If I will hit OK and I will hit apply, we're going to have that plane added. For the plane, I can further adjust it. Keep in mind that this is a plane and this will just be a visual representation, because this will actually be, let's say, going to the infinite. So this is just a visual representation of that plane. If I will select that, we're going to have the following plane over here. Now, if I will go within part design and I want to define a new sketch on that plane, we can also measure over here between our initial reference and this plane. We're going to have the following distance. We see a small deviation of 0.7 degrees, but overall the model has been quite well aligned over here. If I will go to mechanical design, part design, and I will remove this transparency, so the mesh will look like this. I will select this plane to define a new sketch. This will take me normal to like this, so I could also further adjust it over here. I can also hide that plane, and if I will do over here an oriented rectangle, I can start defining that bottom flange. So over here something like this. Now we see within the generative AI model that this will not be a perfect rectangle, and in this case, for a part like this, we see over here that the part actually had that that cutout over here, that relief. So we have a chamfer over there at the bottom. So it tried to replicate that, even though we see over here this will be more rounded than within the reference. Over here this will be a straight cut. Now I can also adjust a little bit this rectangle, so maybe something like this. I will maintain those 90 degrees over here because I want to keep that. So I will add over here a distance. Let's round this up. And now we're gonna see the depth of this. So somewhere along 20 millimeters, we're gonna have the following element over here. Now for this cutout section over here, we can do the following approach. So I can select the top plane. I can change the visibility to be wireframe, and I will just do cut like this, even though the mesh has been further rounded. I can also close this, so I can work directly within part design. I would have the possibility to do a cut over here, but I will keep it like this. So I will just do a straight pocket, and the output will be the following. Now for the middle part, we could go and define a revolve over here. So if I will select either the Y and Z plane or the Z and X plane over here, and I will enter a sketch over there, I can now do a cut part by sketch plane, so I can see that interior. I can define an axis over here, which will be over here. And I can start working on the following profile. So we see over here we have that bottom section. I can also add that over here directly, because we're gonna have that transition. So let me just rotate to the other side, and I will start the following sketch over here, so something like that. And afterwards, with a straight line, I will go upwards. I will select this. In some cases, parts like this should be drafted, so they can be manufactured. But in this case, I will just go for a vertical orientation over there. I can also go over here and add a small fillet, in this case 150. And all that I have to do is this point, I should either constrain it over here on the top or I should overlap it, but I can have it coincident over there. And over here on the top, we're going to define that final distance. Now for the interior, we're going to have that profile. So initially I can just fill this all the way to the axis and afterwards do a cut for the top section. So let's do the following. Over here I will close this since I'm within part design, not within surface. Otherwise CATIA will do that automatically. And if I will do the following shaft, we're going to have the following profile. So again, we're going to see those deviations from the cylindrical profile within that. And we also have that rib. So usually ribs have the following profile over here. Within CATIA they are called stiffeners, and they will maintain the same length and width. So let's do the following. I will create a sketch over here. If I will position it just like that, and if I will go over here and enable the we're going to have the following topological profile, so invalid profile body. This should go all the way into the part. Let's further adjust that sketch. So if I will select this, if I will go normal 2, we're going to see over here that the normal 2 will have that 0.7 degree between this plane and the middle plane, so we have a slight problem over there. And if I will take this profile and take it like this, let's see if the rib, so it will not be able to do that rib. So we have the following possibility. We can just do a manual triangle, even though usually ribbing is a lot better. But if I will do it like this, we're gonna see the following profile. So I can go with mirror extend, in this case 10 millimeters, and we're gonna have that profile. And now we can further adjust the alignment, so to better fit that. It will be something like this. We see also that the mirror of the AI tool is not that great, and that was visible over here. So we see this rib on the right side and the one on the left. Those will be quite different. If I will select this and I will have it mirror onto the other side, again we're going to see those deviations over here. And usually a part like this will have that internal mirror for those ribs, those stiffening elements. Other than that, I consider that the tool did a good job over here trying to define those that middle cutout, even though this profile is far from something that would be within a mechanical part. And we have the other section over here, which the AI tool tried to generate. It added a bit of more geometry over here on the top. While we're going to see the reference, we'll have that those straight lines. And afterwards, over here, we're going to have a fillet that will go all the way through. So I think that the main problem with generative AI is that they don't really understand the models that are CAD models regarding this. So it's a little bit trickier to understand the features, and if those could be, let's say, tweaked within the solution, I'm sure that generative AI will have a major impact within the computer-aided design industry. Currently, none of the solutions are trying to focus on CAD. Mostly they went for organic freeforms, mainly, for example, characters and so on. And Within a previous video, I created a video for this. So we have the bust of an orc character, and we see how well that bust has been defined by the generative AI. We have some slight problems. Over here we have some small, let's say, horns that are not present over there. We see that this reference had a little bit of, so let me just open this in a new window. So we see this is the reference, and over here this is actually the perspective for the other ear of the character, but the AI tool generated that as well. But if we're going to rotate, we're going to have this small horn over there, so that can easily be fixed. We can just smooth that within Blender, and I already addressed that within my other video. But other than that, we see the proportions are really good. Even though over here for this, we're gonna have those two spike horns over here, and within the resulting mesh, we only have one on each side. So that's also a little bit different. And the generative AI added additional elements. So we have one over here in the back, where we see that we have some reference to the back, but overall the total number of components is a little bit different. But still, this is impressive considering that this was all based just on a single image, and the AI tool managed to create this mesh that we can further refine. For example, over here for the nose and other elements require a lot of work, but this is a great starting point for generative AI. Okay, so this video was mostly focused on CAD applications of generative AI. And in some cases, this can be useful, but since the algorithm is not specially defined for CAD parts, this will be a lot trickier in order to obtain good elements. But we see that over here it managed to have this cylindrical shape quite well defined, even though over here on the top it had a lot of problems, and we're going to have a large deviation going upwards. Even though this part should have a little bit of draft, but not that much in order to have that deformed as an ellipse. Mostly it should be just a transition from one small circle at the top to one at the bottom, and that can be easily done using draft angle within CAD solutions. Okay, so I hope you enjoyed this kind of content. I will position a similar video over here on the left side, and I will also add the subscribe button to the right. If you enjoy this kind of content, you can also consider to support me. So you're going to find the link over here at Buy Me a Coffee, and that will help me to create more similar videos. So that's it. Thanks for watching.